Hi guys, welcome back to the channel. So today we are going to be solving weekly contest 394 third question, which is minimum number of operations to satisfy the conditions. So we are given a grid which will consist of m cross n, and then in one operation we can do this particular operation, which is suppose let's say we are at this particular grid, which is grid of ij, and then we are going to mark grid of ij equal to grid of I plus 1 j. That means the same column cell which is going to be next cell, we are going to mark it as same, and then to the right of this particular cell there is going to be one more cell, and then it should not be equal to that particular cell, and then we need to return the minimum number of operations that are needed for this particular grid. Suppose let us take this particular example where we have this. So for this we are going to say this grid has the column contains same colors. So if we see here, it can have grid of ij from 0 to 9, and then the same column should have same value. That means if it contains 2, then every column should contain every row which is present in this particular column should contain 2. For this 0 it is going to have same, and then for this it is going to have same. And then one more thing is, suppose let's say grid of ij should not be equal to grid of I and then j plus 1. That means this one should not be equal to this, and then this one should not be equal to this. So we need to maintain this. So for this, we are going to use one of the example, and then we are going to figure out like how we can solve this particular solution. So suppose let's say if I want this column to be transformed like this, like grid of ij equal to grid of I plus 1 j. That means I'm going to match every column to the same value which is present. So it can be like 2 or 0 or 1, or it can be 9, or it can be 8, or it can be 7, or it can be 6, or it can be 5, or it can be 4, or it can be 3, or it can be 2, or it can be 1, or it can be 0. So these are the different possibilities which we can have for this particular column. And then after having this particular column as some certain value, we need to find the value which is not out of this particular value. Suppose let's say I have here the value as let's take the value as some previous value as 1. Now I need to find the operations which are required so that this column can have the value of 1. That means we should consider k from 0 to k should be less than 10, and then k plus plus. So this should be our consideration. We can consider any of this, but it should not be equal to k should not be equal to previous one at this particular column. This is going to be for column plus 1, and then the previous is going to be for column. So for this column plus 1 we are going to consider k equal to 0 to 10, and then it should not be equal to previous one. And then suppose let's say I want to change to particular value. That means let's say I have 1 0 here. Now I need to transform this 1 0 to only value which is 9. That means it should not be equal to 9. Though it should, suppose let's say this is 1 and then this is 0. So if it is not equal to 1, it is not equal to 9, then I'm going to consider as one more operation. That means I'm going to change here, and then if this is 0, then it is not equal to 9. So that's why I'm going to consider this as again one more operations which I need to do. So for each grid column, we are going to consider the cost of this particular column to be transformed to particular value. Suppose let us see that. So if I consider like, I'll consider for only k equal, some value equal to 9. So for this it needs to be 9. So for this column it is going to be 2, and then for this column it is going to be 2, and then for the third column it is going to be 2. So it is going to be like this 2. Why? Because it is k should be equal to 9, but this 1 is not equal to 9. That's why I'm going to use one operation to this and then one operation to this. and then one operation to this, and then one operation to this, and one operation to this, and then one operation to this. And then let's say I take k equal to 1. So for this k equal to 1, I am going to consider this value is equal to 1. So I do not need to use one more operation to this to change to 1. So that's why we are going to change this 0 to 1 with only one operation. So for this it is going to require only one, and then again for this as well it is going to require only one. So for this it is going to require only one, and then for this it is going to require only one if I want to change to value 1. And then I'll do, after transforming this to particular k equal to 1, I'm going to call the recursion with this particular column plus 1, and then previous value as some particular value, and then whatever the operations which we are needed, we are going to add into our answer. So let us see the code for this. So I'm going to take dp, which is going to have the number of columns, and with this particular value which is going to be our color, and then this is going to be our cost to convert to this particular value. And then let's say we are going to pick m equal to grid dot size and then n equal to grid of 0 dot size, and then we are going to mark the dp as -1 and then cost to be 0. And then for each row and then each column we are going to consider different value to be changed. Suppose let's say I want to change all the rows which are present in this particular column, all the rows which are present in this particular column to be 1, or 0 or till 9. For that cost of jk, it is going to be grid of ij should not be equal to k. That means we are going to use this particular operation when it is not equal to k, and then we are going to add into our answer. And then at last we are going to call the recursion of 0 comma 0, which is this 0 represent the column, and then this 0 represent the previous value which is present. And then for this recursion we are going to say, suppose let's say all the columns are done, all the columns are completed, then we are not going to use any operations. That's why we are going to return the answer. Suppose if this particular subproblem is already solved, that means it is not equal to -1, then we are going to return dp of column of this particular p, means this is going to be our previous value which is present before this particular column. And then we are going to mark the maximum value which is 1 to the power of 9, and then we are going to take different options. It can be from 0 to 9. And then suppose let's say if this particular column is 0, that means this is equal to 0. That means we can consider any value. Why? Because the previous value is not there. That's why we can consider any value. Suppose let's say if this is this particular column, then the value should not be equal to this particular previous value. So that's why it should not be equal to particular previous value. And then we are going to pick minimum of these operations. So it should be cost of ij to cost of column k. Why? Because we need to transform this total column to this particular value which is column which is k, and then we are going to call with the column plus 1 with the previous value as k, and then we are going to return as dp of column of p. So if we come to the time and space complexity, if we see the time complexity, it is going to be big of m into n into 10. Why? Because we are considering, we are going through all the elements which are present in the grid, and then we are going to consider different possibilities. And then if we come to the space complexity, it is going to be big of n into 10. Why? Because we are taking this one. It is going to be number of columns, and then this is going to be 10. Yeah, that's all for this video. Thanks for watching the video.